Ooh, that's bright. This is Universe Sandbox 2, or Squared, however you want to. Anyway, this is actually one of the prettier games I've seen because it basically redoes the universe. Well, right here, we're only looking at our solar system. And they're actually pretty good when it comes to all of the mathematics involved in it, because I mean, obviously, if you're going to be tracking this sort of stuff and predicting things like orbits and various patterns and whatnot, then yeah, you need the mathematics to be pretty damn good. And I actually talked to one of the people at the studio not that long ago, a couple months ago, and I asked them a bit about the game, and they were just like, well, the math is a big deal. They want to make sure they get it as right as possible. Of course, it's not going to be 100% perfect. That happens. Because the computing power needed for, to track all of these different celestial bodies. It can be real difficult to get all that down. But they try to get it as perfect as possible. And because of that, having a better CPU is actually a pretty big deal. Because this game will actually utilize every single core and thread that your CPU offers. So like me, I've got an 8-core, 16-thread CPU, and the game uses all of them. It doesn't top everything off at 100%. It doesn't do that. It usually keeps about 30 to 60% or so, but it does give my CPU a pretty good workout because of all the math that it has to do. So yeah, it definitely utilizes all of the threads, which I think is good, obviously, because I want the math to be as right as possible. But enough about the technical stuff. Let's see if we can't get in here and look at some stuff. Here, we'll look at Earth, obviously, because that's where we are. If I can zoom in on it here. Whoa, careful. Now, it's spinning really fast because our time lapse is pretty quick here. I can stop it. And then you can take a look at Earth. And the graphics are pretty darn good. Look at that. Looks nice. Very pretty. Of course, I'm a little concerned with the lack of ice down at the South Pole, but we'll not worry about that right now. But yeah, here we've frozen everything, so we can go on to other places, like here's Mercury. Everybody, oops, let me just go back. Come on, highlight Mercury. There we go. Let's move in on Mercury, and ooh. It looked like a big giant black hole, but nope, it's just Mercury. And having seen actual photos of Mercury, this is a pretty good likeness. Yeah, Mercury is basically a big giant iron nickel ball. This is actually really nice looking. Very pretty. Very impressive. And for those of you who may be wondering already, oh, you were probably given the game for free. No, I actually did pay for the game. It's not just, one of the people at the company didn't contact me and say, hey, we'll give you this game if you speak stellarly of it. No, I paid for the game. Like all of you should, if you want it. But here's Venus. Venus is kind of plain Jane, but I mean, that's kind of how Venus really looks. It's basically just a planet covered in clouds. Of course, those clouds are highly acidic, and the pressures there will pretty much instantly kill you. The pressures and the temperatures will kill you. So don't plan on going to Venus anytime soon. That's going to hurt. Let's see, where's Mars? Where are you, Mars? Here you are. Let's head on into Mars, our future home. Or at least for some of us. Well, looks kind of neat. Mars does have ice caps. Yeah, but those are, if I remember correctly, those are our carbon dioxide ice caps. Looks kind of nice. Alright. And then beyond Mars, there is the asteroid belt. Can't really see it too much there, but it does list off some of the larger bodies. There's Ceres, right over there. Let's see, there's Jupiter. Let's zoom in onto this guy. The big one. The big daddy of the solar system. Oh, there's the red spot over on this side. Pretty neat. Does not have its rings. And yes, Jupiter actually does have rings. For those of you thinking Jupiter doesn't have rings, it actually does. They're very, very, very faint, but they're there. Speaking of rings, let's find Saturn. And surprisingly, Saturn doesn't have its rings. Come on. Come on, guys. You gotta put the rings on Saturn. Ugh. I mean, the color of the planet itself looks pretty right on, but there's no rings on Saturn? Come on. You gotta put that on. Ugh. Well, that's a fail there. Well, let's see. After Saturn, we've got Uranus. Yes, let's all laugh it up here. The funniest planet ever known. And as you can see, there's its butthole right there in the center. Everybody enjoys Uranus. Still a cool planet. I noticed there's no rings around this one either. And yes, it does have rings. Let's see, where is Neptune? Heading over to Neptune. Oh, there you are. Very dim, but that makes sense because it's pretty damn far away from the sun. And it does have the blue pretty much right because of the methane. So pretty good. Not bad, not bad. And then let's see if we can't find our buddy Pluto, who is not a planet anymore, but we'll still give Pluto a little love. Again, very, very dim, but I actually expected it to appear a little bit brighter because of the reflectivity of all of its ice. Again, I've seen pictures of this, and it looks pretty right on, except for the reflectiveness. So we'll zoom out of Pluto. And let's see. We've got our sun there in the middle. I don't think you can figure out what I'm trying to point at here, so let's zoom in a little bit more. There's our sun, nice and bright. Some of you who aren't familiar with the behavior of celestial bodies, you'll see this little tail here. Now, that's not a real tail, so to speak. That is the path that the sun is taking as it goes through space. So, yeah, the sun isn't static. It does move around, obviously. And we do move around the solar system, so that's why it's showing that. Very... Ooh, a little too bright. Okay. So, the best thing that we can do in this game is cause massive amounts of chaos. So, let's try to figure out what we can do to make the solar system just go insane. Now, we can go in here and we can make the sun twice as big, which would really play havoc with the planets. We can add another planet. We can make a planet smaller. We can make a planet bigger. Just all kinds of stuff. So let's... Messing with Mercury is a little too easy, because I know what'll happen. It'll just... If we make it bigger, it'll just slowly spiral into the sun. Let's see. What can we do To really make things weird. Jupiter. I could make Jupiter explode. And then that would cause a lot of weird stuff to happen. Just zoom in a little bit. Auto energy. There we go, we got things moving again. Kill that. And as soon as I cause this thing to explode, we may see a bit of a slowdown because my cores are going to go insane here in a moment. So here. Explode the selected body. Explode, damn it! Why aren't you exploding? Probably because I didn't put any force into it. That's not that big. At least I don't think it's that big. Okay, so it's not exploding. I'm probably doing something wrong. I admit I don't have a lot of time in this game. So let's try something else. Oh, here we go. Motion, temperature, materials, actions. We can change the mass. The mass is a big thing. Let's change it to 500 Earths. There we go. And that should make things a little weird. Hopefully. And if we go to Mars, we'll make it 100 times the size of the moon. Or not. Oh, okay, 1.23 Earth. Okay, that works. Well, nothing too wild so far. We've changed the orbits. Jupiter's a little different, Mars is a little different. And Earth. Orbit of Earth has not really changed much. Mars is slightly closer, though. Well, we have to cause even more havoc. Because this is not much. Let's see. Oh, Jesus, that's a bit bright. Tools, here we go. Add. Let's add something. So here we go. We can add a planet or star. Kepler 10b. We can add a star. That'll make things go nuts. Here, let's add a ridiculously large star. That one's not that big. This one's twice as big as the sun. That one's kind of small. That one's even smaller. And ours. Betelgeuse is really big. 6.7 suns. 2.14 sun. 950 Jupiters. 19 suns. I also don't want to use one that's too bright because then we can't see what's going on. Let's use Betelgeuse. We'll put Betelgeuse somewhere interesting. Ooh. Okay. Oh, too close. Too close. Too close. Gosh, just to give you an idea, look how much bigger it is. Here, let's stick Betelgeuse. How many is that? 65 astronomical units. Let's put it at about 20. There we go. Oh man, what just... No, I didn't want that to happen. It just ate everything. Oh crap. Maybe 20 astronomical units was too close. Let me see. I can start this over. Let's see. Or I can go and open up existing simulations. Let's see. Ultimate Energy Solar System. Tesla Roadster in space. Where in space is the Tesla Roadster? Alpha Centauri Triple System. Solar system with no sun. Everything would be frozen. And probably fly off. Planets between the Earth and Moon. Planet 9. Oh, look, there you go, Saturn with rings. Well, let's pick something. Let's just, for the fun of it, choose that. I'll load that up. Excuse me. Yeah, this is where the Roadster is, apparently. Or where it will be. Oh, okay, look at the date. Here we go. So this is where it was in February. On February 6, 2018, SpaceX performed a successful test launch of their Falcon Heavy rocket, the most powerful rocket currently in use. Wow. The launch was intended as a demonstration of the Falcon Heavy rocket, Falcon Heavy's ability to launch a payload into an orbit that could reach Mars. SpaceX also successfully landed 2 of the Falcon Heavy's reusable booster engines. It's not bad. It's worth to note that this current simulation is slightly visually incomplete. Oh, okay. Our payload object, the Tesla Roadster, depicts just the car. Really, the Roadster is attached to the second stage of the... Okay. So it's only showing the car, but there's actually a piece of the rocket still stuck to it. That's funny, though. Random car in space. That is kind of neat, though. And it shows you where it hopefully should be. Man, it also shows you how small that thing is. I'm going to have to zoom out a lot. And there's Mars, way over there. That's kind of interesting. Let's see. Cassini collision with Saturn. Oh. I remember hearing about this. And there's all the moons. And kablooey. I guess I expected a little more, but I mean, when you crash a satellite into something that big, it's not going to be amazing. It's amazing in the sense that it's like, wow, we were able to do that, but not amazing as far as collision. Planets between the Earth and the Moon. That's just weird looking. I guess this is just to demonstrate the distance between the Earth and its moon. Oh, this is all the rings of Saturn. Okay. And there's the moon. Make a quick adjustment here. There we go. Excuse me. Let's see, Earth and Moon. Let's do solar system with no sun. Yeah, we're just pretty much flying off into everywhere now. It's kind of, yeah. Jupiter will probably gather up some asteroids make a little mini solar system, but that's a bit boring. Solar system now in real time. Apophis encounters Earth in 2029. In 2004, astronomers discovered the large near-Earth asteroid Apophis. Months later, studies showed that it had a 2.7% 1 in 37 chance of colliding with Earth in 2029. Oh, interesting. Further studies significantly reduced this probability, and concern about an impact with Earth in 2029 disappeared. But then concerns rose again, this time about Apophis's second trip by Earth 7 years later. It's believed that a close pass by Earth in 2029 could bend its orbit and result in an impact in 2036. By 2013, though, NASA concluded that, with further observations, there would be no collision the second time around either. Still, Apophis is expected to pass just 18,300 miles above Earth's surface in 2029, a record-setting close approach. Initial studies of Apophis gave it another record high rating of 4 on the Torino scale, which measures the likelihood of a comet or asteroid colliding with the Earth. It's estimated that if Apophis did impact Earth, it would release energy equivalent to more than 1 billion tons of TNT exploding. Thankfully, any chance of impact has now been effectively ruled out. That's still kind of scary, man. Jeez. I wonder if it will be something that we could see with the naked eye. It doesn't really address that. I mean, if it's going to be that close. Wow. It's a bit creepy, but, you know, it's not like we can really do anything about it. At least not right now. Ross 128 with Earth-sized planet. Two baseballs 1 meter apart. Okay. This is silly. I think they're gonna collide. This is kind of silly. They didn't do anything. I was expecting like an explosion or something. Earth and 200 colliding moons. This will be neat to watch. Let's put this up here. Oh god. Yeah, it's safe to say that all life on Earth has been wiped out. Yeah, my cores are going crazy right now because of all the little fragments. And it's gonna get worse. Oh, look at that big one. The big one right there. Everything's just getting... Oh, and Earth swallowed up that one. Ugh. Now the mass of the Earth is getting quite big, I imagine. I think some got flung out, yeah. Some pieces got flung out. Look at that thing. Oof. I wouldn't really call it a downside, but the one interesting thing I've noticed is that the music, I mean, the music is very soothing, but it makes me sleepy. I mean, it fits, but again, it makes me sleepy. It's pretty interesting. Yeah, the Earth is hotter than heck right now. Oof. Probably still got a few more collisions in there, but things are starting to settle down a little bit. And all those little bits are going to eventually get eaten up by Earth. Look at all these, some of these bits you can't even see. I can only tell they're there because I'm running my mouse over them, but there are so many of them. All tiny little asteroids, really. Ooh, that planet got torn apart. To kind of jump back to the CPU information, like I said, this game benefits from more cores, so that's a big deal. Interestingly enough, you don't need the best graphics card. I mean, it looks pretty. You don't need the best graphics card though, so you don't need like me. I've got a 1070 Ti, which is a pretty high-end card. But you don't need one of those. You can probably get some pretty decent results with like a 1050 or something, or even less than that. Like, I think the first time I played this game was on a 970. That was, for that time, it was still a pretty good card though. But I still don't think even a 970 to run this game. But like I said, when it comes to the math though, you would probably want to have a few more cores. I imagine with these graphics, something even like heck, you might even get decent performance out of a 1030. 1030 is pretty low end. I really have no idea how onboard graphics would work. Like I know Intel has those onboard HD graphics. I don't know how those would work out. I've never actually used Intel HD graphics. Looks like most of the action is done here. Still a few more things. But while that's playing out, let's start looking over this. Total eclipse. Another solar eclipse. TRAPPIST-1. Earth and 50 colliding moons. That's what we're doing right now. Earth and 100 colliding moons. Oh, I'm sorry. We're doing the 200 colliding moons. Not the... Okay. I didn't realize there were multiples of that. Nearest 400 stars. A binary pulsar. Wow. Earth and 2 close moons. I imagine those would probably collide. Earth and 2 further moons. Earth and close moon tidally locked. Black hole and sun. Earth and 8 Ceres. I'm thinking about that one. Saturn and Neptune, no rings. Saturn and Earth. Earth at 1000 degrees C. I notice they just keep going up in temperature. At some point, they're just stars. Even though Earth doesn't have the mass to be a star. At least I don't think it does. Even something like a red dwarf is bigger. Although I can probably look up red dwarf. Mathematically speaking, I imagine there's a minimum amount of mass generally that a star would require. Although I'm sure those numbers are flexible because, ooh, every day we're finding new and amazing types of celestial bodies out there. Voyager 2 and Neptune in 89. Physics. Well, I'm sure we'll get a lot of impacts on this one. Let's do the Earth in 8 series. Oh, it's tearing them all up. Well, it's tearing up the inner ones. The outer ones are surviving. Six is starting to go now. I think it's because their orbits are decaying. 7 and 8 still seem to be holding together. But I imagine as their orbits decay, it's going to get worse. Not as explosive as I thought it would be. Well, this is only a day in. Got our timer over here in the corner. Yeah, 24 hours in, and one day we just passed the 1 day mark. So within a day, 6 of them would start to crumble and fall apart. Be torn apart by the gravity. And 7 and 8 have managed to survive. I do wonder how large the pieces of the inner ones would be. Would they be large enough to cause a real problem when falling into Earth? I imagine some of them would be. Because I know Ceres isn't that big, but on on a celestial scale, they're not that big. But when you take something even 5% or even less the size of Ceres and impact it into Earth, that's gonna be a huge concern. Yeah. This one's not as exciting as I hoped it would be. Let's see if we can't binary Earths. Binary Earths at half radius. I imagine these are going to be collisions. So let's see what these do. Oh, they're heating up because of how close they are. The gravity from each other are making their innards go nuts, so they just get hotter and hotter. They destroy all life on Earth, boil away the oceans. I imagine over a long enough time period that they would just tear each other apart and probably coalesce. Interesting simulation. So it's been about 3.5 days on their time scale. Can you imagine something like this happening on Earth? To go from perfectly pleasant to shit's on fire, yo, in about 4 or 5 days. Well, we wouldn't even be alive on the 4th day, because within the first day everything was gone. It was just Let's see. One spinning. Half radius. Locked still Earths. That's one thing I noticed. They're not rotating. Let's look at this one. One with rotation. Oh, ooh. What's... Wow, that's weird. For a second, I thought this one was feeding on the mass of this one, but it turns out it was the other way around. Weird. And it's just going to keep doing that? Oh, maybe not. It stops eventually, and then we're left with something like a moon, I guess. Oh, there's still little bits out here, too, which I imagine will eventually get eaten up. But that was an interesting one. Huh. Let's see. Locked Earths, one spinning, two radius. Nothing too big so far. In this simulation, two Earths are placed next to each other at a distance equal to twice their radius and held in place. A side of each Earth that is closest to the Earth experiences a larger gravitational attraction. Ah! We can see now what's happening. One Earth is dying severely because it's being crunched and the temperature is rising. This is large and each Earth stretches towards the other due to tidal force. Each Earth is heated by tidal forces, and then the spinning one is eventually ripped apart, leaving its fragments orbit and collide with the other Earth. That sounds about... Well, hold on. This one, the oceans came back. Let's see. Its mass is still the same, too. The temperature is actually coming down. While the temperature on this one is actually relatively pleasant. It's actually quite pleasant. Average temperature of 12.6 C. Whereas this one is hot, but it's getting cooler. So is this something that it's... It's still getting cooler. I wonder if this is something that would take quite a bit of time to happen. Well, I mean, relatively speaking. And it's still getting colder. So far it's been about 10.5 days. Yeah, it's just getting cooler and cooler and doesn't seem to be slowing down. Now the temperature seems to be slowing slightly. But... Oh my god, oh, now it's speeding up. We're turning into Snowball Earth. Everything's freezing over. No! What is happening? Non-spinning Earth is cooling as well, but not as much. 10.8 C. Cooler, but still habitable. Whereas this one is, oh, it's quite cold now. Oof. Negative 24 C. It's still going. It's slowing down, though. Yeah. And this one, it's getting cooler, too. That's strange. So I guess mathematically speaking, it doesn't really... But then again, neither of them have a sun to warm them, so they're both working off of each other's gravity to try and stay warm. But this one isn't slowing down. But they're both turning into snowballs. Well, this one is a snowball, and this one's getting there. 9.61C. I almost want to throw a sun in there, just for the fun of it. Well, this one's finally steadying. 56C. I just wonder now when this is going to stop. 9.44C. That's quite cool. Quite cool. Now I really want to throw a sun in there. Well, let me at least put it to where it should be. Which I imagine is going to be way the hell out here. It'll tell me 1 astronomical unit. There we go. 1.5, 1.59. There we go. So it's pretty much the correct distance. Okay, yeah, just like that, we got really hot. We're already back to 168C. And this one I imagine will eventually get warmer. Oh yeah, it's starting to warm up now. And this one is ridiculously warm. Well, let me see. Let me launch this one out. It says launch. Velocity in kilometers. How high can I go with that? I imagine I can go really high. But it will take time for it to take off. And 79C. Oof. That's very, very hot. And then, of course, we've got the sun way out here. Let's see if we can find a simulation that goes out with a bang, because this stream's starting to run a little long. Let's see. Asteroid volatile test. Ooh. In this simulation, 50 asteroids, each with a radius of 20 kilometers, orbits the Sun at distances that range from 2% to 125% the distance between the Earth and the Sun in our solar system. The Sun's gravity pulls volatile materials like water from nearby asteroids. This speeds up the volatile loss. Depends on the distance between the asteroid and the Sun. So in other words, the closer they are, obviously the faster they'll break apart into nothingness. Oh, the math is breaking down on this one now. You can see it getting a little funky every now and then right here. But that's the thing, when you get that close, and look at the speed it's going. Yeah. The design looks interesting though. The colors. Oh well. I'll mess around with this game a little more and see if I can't come up with some neat simulations on my own to share. Because I think it's a pretty game. I think it's kind of neat just to mess around with. I mean, it's got it in its title. It's a sandbox. You just go in there and you mess around and do stuff. So I'll do that and see if I can come up with anything neat to share. Until next time, thanks for watching, guys.